The gateway to perception comes in 1,000 shapes, and we adorn it in 1,000 ways. But its real beauty is buried deep in the skull. It's the only sense organ that does two totally different jobs. It picks up sound, and it keeps us on a sound footing. Without this little piece of architecture, our whole framework could tumble down. Tune into the human ear next on Body Atlas. Inside the ears is a delicate mechanism which gives Zita the spring in her step. For her career as an international gymnast, her ears are Zita's most essential organs. They're the gateway for the music to reach her brain, where rhythm and melody are translated into a graceful and inspirational flow of movement. Even more important, Zita's ears contain the organs that allow her to balance. They keep track of her body's every move, whether she's on the ground or flying through the air. Without the intricate mechanisms of the ear, we'd never be treated to a display like this. Even if we can't all perform as well as Zita, our ears keep us constantly in touch with what's going on. They tune into the sounds of speech, the uniquely human way of communicating. Hidden in a cavity within the solid bones of the skull, evolution has manufactured the most sensitive of receivers. Only some parts are used for hearing: the round eardrum, a set of bones, and the snail-shaped cochlea. Our ears can distinguish millions of different sounds, more than any other animal. We can recognize hundreds of friends and acquaintances by very small differences between their voices. We can pick out what they're saying amid a multitude of distractions, and even pinpoint their position by sound alone. Our inbuilt direction finding depends mainly on having two ears. A voice from Zita's left side reaches this ear before her right ear, revealing her coach's exact position, even if the delay is only a few millionths of a second.
Zita?
Ears aren't mirror images. They differ slightly, so they each react differently to the same sound. The ear's convolutions are as individual as a fingerprint. They help to refine our direction-finding sense. As sounds bombard the ear from different angles, these ridges and folds amplify some frequencies and diminish others. They produce subtle changes in sound which we detect without thinking about them. The fleshy outer ear channels the sound waves into the head, down the inch-long ear canal. Hairs and wax keep out dirt and curious insects. At the far end, the sound waves pound on the only barrier between the outside world and the ear's internal mechanism, the eardrum. This membrane is stretched tightly across the ear canal. The eardrum vibrates with each sound, a simple movement that begins the whole process of hearing. From the eardrum, the sound must follow a complex route through the ear before it's finally analyzed by the coiled structure of the cochlea. This will be a journey through some of the body's smallest structures. From the eardrum, the sound travels through this air-filled cavity, the middle ear. It's only 1/3 of an inch wide. The vibrations are passed on by 3 tiny bones. The hammer, attached directly to the inside of the eardrum, comes first. The second bone is named after its supposed resemblance to an anvil. The third is the smallest bone in the body, no larger than a grain of rice. It's fittingly called the stirrup. These bones act as tiny levers, magnifying the pressure of the sound waves over 20 times. But this mechanism also forms a bodyguard for the delicate structures further in. If the eardrum is assailed by a dangerously loud sound, the body's 2 smallest muscles tighten and restrain the wildly vibrating bones. These are the only bones that don't grow during childhood. An adult has ear bones the same size as a newborn baby. This exquisitely tuned mechanism can withstand a surprising amount of rough and tumble. The middle ear can have problems when the outside pressure suddenly alters, stretching the eardrum and throwing the bony levers out of balance. The altitude changes during an airplane flight can be a recipe for earache. As the sensitive membranes are distorted, they send pain signals to the brain. The pain eases as air flows through a thin tube running up from the throat. It matches the pressure here to the air outside. The journey of the sound waves in the middle ear ends with the vibrations of the stirrup bone pressing on a thin membrane called the oval window.